Hello, and welcome back to school. Welcome to San Marin High School. Welcome to STEM Marin, and welcome to AP Physics. So, my name is Nick Williams. Easiest way to get in contact with me is through email, nwilliams@nusd.org. You likely got this video via email, so you can also just hit reply if you are so inclined. Um, a little bit about me. I grew up in Oakland. I spent a couple years living in England during kindergarten and first grade. My folks are from New Zealand. And then after high school, I went to UC Davis. I majored in evolution and ecology, so like mathematical modeling of large populations. And what I spent most of my time doing in college was playing Ultimate Frisbee. I played for the UC Davis men's Ultimate Frisbee team. While I was there as a senior one night, I went out to the grimiest club in town, the Davis Graduate, and found myself dancing with this girl, and then talking with this girl, and then a number of months later, falling in love with this girl, who was a kindergarten teacher. I guess at that point she was studying to be a kindergarten teacher. But I realized a couple of years later, I ended up marrying that girl. But I realized that a lot of what I loved about her and I was falling in love with about her was really directly related to her being a kindergarten teacher. And that inspired me to live my values in life the same way that she was living hers. So I went back to school, also at Davis, got a science teaching credential and a master's in science education. And I have been here at San Marin High School ever since, which was 19 years ago now. So this is a picture. We now have three kids and a dog. This was a picture of us a couple years ago when we were all a little bit younger and a little bit cuter. We live just down the street, and so it's very likely that you will see me walking or running around town with some combination of this set of people. Feel free to stop me and say hi. So, AP Physics is part of our STEM Marin program. And these are kind of our core focuses with foci within AP Physics. All of it builds out of a really strong work ethic. So we are going to teach students how to work really hard, how to solve difficult problems. We're going to do that by building our critical thinking skills and bringing in a lot of physics content to do that critical thinking through hard work. And then we're also going to use a lot of creative thinking, collaborative work, and communication of our thinking processes and our final products. So our big picture course schedule, there are 8 units in AP Physics. It starts with kinematics, which is motion. So we are starting by designing a projectile motion device that will land an object in a consistent place every single time. Then we're going to go into dynamics, which is forces. We're going to design some vehicles and try to apply as many forces as we can to them and see if we can get as many forces at different angles as possible. Then we will do some energy conservation and design some roller coasters. We'll do some momentum conservation in Unit 4, where we'll crash some things together and see if we can conserve momentum under different circumstances. Then we'll do some torque and rotational motion, where we will put together some kinetic sculptures in the model of Alexander Calder, which are basically big mobile things, and try to balance our torques so that they can spin and conserve rotational momentum. And then we'll shift into energy and momentum of rotation and oscillation, where we will design some tree swings and put them in motion. And then finally, we will do fluids, where we'll design a fluid fountain sculpture piece and see if we can get some fluid pressure and motion through that. And all of it is building up to our AP exam, which is going to be in early May. I think it's May 6th this year. And so we'll do a lot of practice for that AP exam. In terms of class structure, we have limited class time, and so we are going to use as much of that class time as we possibly can to take advantage of the resource of each other. So we'll be working all together at the same time and in small groups. I'll be bouncing around from group to group and helping out. And this will be a ton of project-based learning. So designing things, building things, applying concepts, working problems together, going over previous difficult questions and trying to figure out why they're difficult and how we can make them a little bit easier for ourselves for next time. Running experiments and labs, doing collaborative work, and having class discussions. That means that all of the other components shift into homework. So that would be direct instruction and lecture. For every chapter of the textbook, I record a series of videos where I go through the chapter and give all of the necessary information. So that's something that students can watch on independently on their own time. And while they're doing that, they'll take notes in their notebook and we'll talk about what those should look like. They'll do a bunch of practice problems, learning how to solve physics problems. We'll do a practice test, which is called a personal progress check on the AP Classroom website. And then we'll put together an academic portfolio website and write some reflections about that. All told, the goal is for around 30 minutes of homework per night if they are decent at time management and space it out. So it's usually about 2 hours per week, 2 to 3 hours per week, probably is what students say that they take on average. Um, so that would either be watching videos or doing a set of practice problems or taking a practice test and studying for our unit test. In terms of grading, we grade on the AP proficiency scale. So AP is graded on a 1 through 5 scale. A 5 correlates with an A plus, that is doing excellent work. A 4 correlates to an A minus. A 3 is a B. A 2 is a C. A 1 is a D. And it's very difficult to earn a 0. You really got to try not to do anything. 70% of our grade is made up of course content, exams, and project work. 15% is conscientious learning, so that is in-class work, homework, notes, practice problems, and 15% is communication, so that's both written communication in lab reports and oral communication through multimedia presentations and class presentations. The good news is that in order to earn a 5, you need to get about 85% of the test questions correct. On a multiple choice test, that's a 17 out of 20. To get a 4, you need to get 70% correct. To get a 3, you need to get 55% correct. And to get a 2, you need to get 30% correct. You might be looking at that and noting, ooh, I could get 70% right, and normally that's a C minus, and now it gets me an A minus. Ooh, this is going to be easy. Um, and one might think. So we'll see if that comes back around. We'll also be looking at conscientious learning and communication. However, unfortunately, the AP Physics exam is a gnarly one. Globally, we saw a big increase in passing this year, which is great. It used to be 45%, and they got our pass rate up to, I think, 68%, 66%, doing my math real fast. So 2/3 of the students who take it pass it, but those are difficult questions. So only 18% of people who take it earn a 5. And another 25% earn a 4, and then 23% earn a 3. So it is a tough one of the toughest AP exams that's given. Luckily, we are really good at AP Physics here at San Marin. This is our San Marin 2025 score breakdown. Oops, I left the 2024 on there, but this is actually the 2025 score breakdown. We had 18% earning a 5, 38% earning a 4, and 30% earning a 3. So that puts us at an 86% overall pass rate. And of those, it was almost entirely seniors not passing it because they kind of stopped trying towards the end there. So our juniors and our sophomores had a 98% pass rate, which was outstanding. So looking forward to some really good results if our students put in the work. In terms of supporting your student through AP Physics, recognizing that this will very likely be one of the hardest classes that they have taken so far at any level of schooling. We're going to solve real problems and we're going to solve difficult physics problems where when I do them, the first time or two or three, I get them incorrect, and then I have to rethink some of my thinking and try to rework them. Some of the problems we're going to end up doing will take me 35 minutes to get it right. So solving real problems is hard, and it's not unusual to really struggle with it, especially in the beginning. A big part of that is building some self-advocacy, reaching out to me if they're struggling, when they're struggling, because they almost certainly will struggle. Coming in for tutorial. We have access every week, and I would love to work AP physics problems, and just ensuring that they're putting in the time and bringing those questions in so that we can have the levels of success that I know that they're capable of. Other ways to support your students. Please, your kids are lovely. I would love for them to continue to be lovely. And the reason that they've developed into lovely people is because you have been parenting them well. Please keep parenting. Teenagers are kind of the worst. They desperately need you, and then they also desperately need independence. And that's especially difficult in the junior, senior time range where they're growing in independence and they need a lot of that independence. And then they also need guidance because they're still children and we all need guidance. Um, I have a 13-year-old right now. I am hoping and assuming that things get better, but they also get differently tricky. So you've been doing great so far. Please keep parenting. And then, if you are able to contribute to our larger school community, the STEM Marin Fund is the funding source that kind of keeps all of our science classes going. Uh, any ability that you have to get involved there, either through your expertise, guest speaking, willingness to do some work, or financial contributions would be tremendously important, tremendously valuable. And then finally, San Marin has an awesome parent teacher student association. Please get involved with the PTSA. They do awesome work for all of our students. Thank you so much for watching through this. Really looking forward to this year with your students. Super excited to work together and have a wonderful rest of your year. Thanks so much.